My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 253. In this lecture, I will continue my discussion on Amazon Fine Food Reviews dataset. In this lecture, we will try to understand converting text into vector. In this context, text means that is review text. We will try to understand. Just if you recall my previous lecture, we were discussing about all these features. How many features are there? There are 10 features. Now what we will do, you need not bother about ID. This is one feature, and another feature, score. Let me remove these two features, ID and score. Totally there are 10 features, from which we are not carrying these two features. Now let me consider these 8 features: product ID, user ID, profile name, helpfulness numerator, helpfulness denominator, time, summary, text. By using these 8 features, let me write otherwise. Let me say like this. Yes, given these 8 features, or I can say 8 variables, what I have to do, predict. I must predict. What I have to predict? Predict sentiment polarity. Predict sentiment polarity. Isn't it? Polarity basically means positive. Polarity means what? Polarity means is it positive review, positive or negative review? That is polarity, isn't it? There is another name for negative review, that is critical review. That's what we discussed in our previous lectures, isn't it? How are you determining whether positive or negative? We are determining from score. That's our problem definition. If you notice, the most useful, now we are not considering score, that you must understand. Now I am not considering ID and I am not considering score. I am considering only 8 features. The most, if you notice, the most useful feature among all these 8 features, just think from common sense point of view or common sense perspective. If you just think about the most useful feature, or in these 8 features, the most useful features are 9 and 10. What is 9th one? Summary, brief summary of the review. I already discussed what is brief summary of the review in my previous lectures. I also discussed about text of the review, isn't it? This is common sense. When anybody can say these 2 points, summary and text, plays a crucial role in deciding, in predicting whether it is positive review or negative review. The most useful features are summary and text, isn't it? I can say summary and text. If you observe these 2 features, summary and text, the summary and text, both of them are basically text. What is this? Basically text. If we speak strictly, it is English text. Is it not? It is English text. The most important thing we learned in linear algebra, just try to recall what we did in linear algebra. The most important thing we learned in linear algebra classes, given any problem, if you can convert into problem of vectors, given any set of data, if you are able to convert into vectors, you can make use, you can take leverage, you can take advantage of linear algebra, you can take advantage of power of linear algebra. We in linear algebra classes, we discussed about equation of plane. I already discussed about equation of a plane, isn't it? Just I request you to go through those lectures. Even we discussed about dimensionality of a point. We discussed about dimensionalities also we discussed in linear algebra classes. All these things are useful in understanding these reviews. We learned about all mathematics in linear algebra, all required mathematics in linear algebra. Now, if you convert everything into vector, we can use mathematical power. You can use, if you are able to convert, these reviews into vectors, you can make use mathematical power. You can make use mathematical power of linear algebra, which we discussed all concepts which are required for machine learning. We discussed in linear algebra classes. I request you to go through those classes. Among all the features, the most important features are summary and review text. That's what we were discussing. That is 9th and 10th one. Just see, in all these things, which one is important? These are important. Which one is important? Just let me show you. This one is important. Once if you are able to convert these two features, summary and text, into vectors, I can make use concepts of linear algebra in understanding, in analyzing these reviews. We will try to understand how to convert this summary and text or review text into a vector, isn't it? Question, let me say like this. Here question is, how do you convert? How do you convert? How do you convert simple English text, simple English text, simple English text. Text here consists of words and sentences into a vector. That is a question that we will try to understand, isn't it? This text means what? This is English words. Text means this is English words, isn't it? That can be English sentences, isn't it? In review or summary, you can find English words and sentences. How do you convert? How do you convert? Otherwise, let me rewrite it. How do you convert? My biggest question is, how do you convert? How do you convert text? How do you convert text into mathematical vectors? Mathematical vectors. That's important question. That mathematical vectors, or I can say numerical vectors, or I can say mathematical vectors or numerical vectors. That's important question, because if you figure out how to do it, then you can make use concepts in linear algebra. Let me give an example here so you can connect the dots. Imagine my review text. Just imagine my review text is, just refer what is my review text. This is my review text of the review. As I am saying, just take summary, isn't it? There are text. This is my text of review, I can say. Text is actually text of the words, isn't it? If somehow convert this review text into a vector, convert into a d-dimensional vector. If I convert every review text, if I convert, let me write, if I convert every review text into d-dimensional vector, I can take advantage of linear algebra, isn't it? Why? Because we have an idea on linear algebra vectors, isn't it? If you are able to convert your review text into how we have to convert into d-dimensional vector. That's our idea, isn't it? If suppose all of my vectors, let me assume like this, suppose if all of my vectors, if suppose all of my vectors are like this, each point represents a vector. This is a vector, this is a vector, this is a vector. All these points are representing vectors. Let me say, if suppose all of my vectors are like this, each point in this plane represents a vector. Each point here represents a d-dimensional vector or d-dimensional representation of a review. Each point represents a d-dimensional representation of a review. This is d-dimensional representation of a review. This is d-dimensional representation of a review. This is d-dimensional representation of review. This is d-dimensional representation. Just assume. Just this is not 2D. This is not assume this is not 2D. For simple, this is some let me assume this is some d-dimensional space. Let's assume this whole thing in d-dimensional space. This is not in 2D. If it is the case, now the data is like this, then I can draw a hyperplane. Can I draw a hyperplane? Certainly I can draw a hyperplane. Just see, I can draw a hyperplane like this. Just let me say this hyperplane is pi, isn't it? Let me repeat. Now the data is like this, then I can draw a hyperplane. We learned about hyperplanes in linear algebra classes. We can make use all of the concepts in hyperplanes in understanding these reviews. If suppose all of my positive, let me say, as I am saying, these are d-dimensional vectors. These d-dimensional vectors are representing reviews. How many types of reviews do we have? We have, let me assume, there are two types of reviews, positive reviews and negative reviews. Let me say this one indicates, let me assume the points which this, let me say these are my positive reviews. These are my positive reviews. Let me assume all these are negative reviews. All these are negative reviews. What I have to do, I will find a plane pi. Let me say this is plane pi with some normal, let me say w. This I already discussed in my regular linear algebra classes. So that I will try to find a plane pi with a normal w such that on one side of the plane we have all positive points. Let me say these are positive points, and on other side of the plane I have negative points. Let's assume I can find this given any point x. Let me say given any point x. Given any point x. Given any point x, if it is in the direction of the normal, if it is in the direction of the normal, if it is in the direction of, if it is in the direction of normal of the plane, in the direction of the normal of the plane, in the direction of the normal of the plane, in the direction of the normal of the plane, then W transpose X is positive. Then I can say W transpose X is positive, isn't it? On the left, I can say here I'm assuming this is direction of W. Let me say this is X. In that case, W transpose X is positive as they are in same direction, which we discussed in our linear algebra questions, isn't it? Now, what is W? Let me assume, otherwise, let me assume I have 2 points here. Let me say this is my x1. Let me say this is my x2. Let me say this is my pi. Let me say this is my normal W to this particular plane. Let me try to identify W transpose x1 value and what is W transpose x2 value. Because here you must understand W is normal to the plane, normal to your plane. Remember, we learned these in linear algebra chapter or linear algebra lectures. When we learned about equation of the plane, I discussed about this one. Your W transpose X1 is positive. Your W transpose X1 is positive. What is the reason? Because your W and X1 are in the same direction. W and X1 are in the same direction. This I already discussed in linear algebra classes. Just I request you to refer that. W transpose, what about W transpose X2? On this W and X2 are on different side. This W transpose X2 is a negative. What's the reason? W transpose X2 is a negative. Why? Because W and X2 are in different side. This is not new thing. We already discussed in our linear algebra classes. This concept is very, very useful in understanding. This particular concept plays an important role in deciding whether a particular review is positive review or negative review. I will discuss all these things in my future lectures. Let me say like this: W transpose Xi. Let me say W transpose. If W transpose Xi is greater than 0, then my review Ri is positive. Isn't it? If W transpose Xi is greater than 0, it's positive. Else, what can I say? My review is a negative, isn't it? My review Ri, which one? My review Ri is negative. If I can somehow find this W, I can decide whether a particular review is positive review or negative review. This is the power of linear algebra. As I told you, first we will try to, if you are able to convert these reviews into vectors, I can make use those concepts. I will spend a lot of time in future classes, like in logistic regression and support vector missions. There I will spend a lot of time. Time being, just let me proceed further. I am just giving the intuition on why linear algebra and why representing points in d-dimensional vectors is useful, why it is important. We will anyway, I will spend time when I discuss about logistic regression, geometrical interpretation, even we'll spend time on support vector missions. There I will discuss a lot. Time being, just refer my previous lectures on linear algebra so that you can understand these things. Time being, just understand there is a math behind this review analysis. If you are able to, if you feel that intuition, it is useful. How it works, we will try to understand in future classes. Now, here is the most important part. I am connecting the fact that if we can represent a text or sentence or paragraphs in English as d-dimensional vector, and if the vectors are like this, I can say these are, I am assuming these are vectors, isn't it? If somehow, if I am able to find W that is normal means this is something like this is perpendicular. This also we discussed in linear algebra classes. If W transpose Xi is greater than 0, then I can say review Ri is positive, else I can say review Ri is negative. We will solve this problem later when we learn techniques like logistic regression and support vector missions. But you understand the idea that linear algebra is extremely useful for converting review or text in a review into a d-dimensional vector. This is the first step. Once if I convert this review into text, once if I convert this review text into d-dimensional vector, into d-dimensional vector. What I have to do? Next, I can think about finding a plane. I can think about finding. After this is first step. First step is you must convert review text into d-dimensional vector. Now what I have to do? I must think about finding. I can think about finding plane. Finding plane to separate these vectors. To separate vectors. To separate reviews, isn't it? That's next step. First step here is there are multiple converting. First step here is I must convert my review text into d-dimensional vector, isn't it? Now the big question here is what are the properties of this conversion? So I am trying to convert text into, what am I doing here? Yes, what I am doing, I am trying to convert text. I am converting text into d-dimensional vector. Into d-dimensional vector, isn't it? I need some rules to convert this one, isn't it? I can say what sort of rules should it follow? The most important rule to follow is as follows. Let's assume like this. Let's assume there are 3 reviews, R1, R2 and R3. I have 3 reviews. Just for simplicity, I am assuming there are 3 reviews. If R1 and R2 similar, let me say these two are similar. R1 and R2 are similar. Let me assume if they are more similar, they are more similar semantically than R1 and R3. Let me assume R1 and R2 are more similar than R1 and R3. Similarity in the sense they are similar in the context of English language. Let me assume like this. Let me assume similarity between R1, R2 is greater than similarity between R1 and R3. As I told you, there are 3 reviews, R1, R2 and R3. This similarity is English similarity. This similarity I can say it is English similarity. If somebody reads these reviews, let's assume I have text R1, R2, R3. If somebody reads this text R1, R2 and R3, if they realize it that R1 and R2 are more similar than R1 and R3. If English similarity, I can say like this, similarity in the sense if English similarity between R1, R2 is greater than English similarity between R1, R3. Let me say like similarity R1, isn't it? Let me say like this, for each review I can say for each review Ri, I have Vi. Vi means vector. For R1, let me assume I have reviews R1, I have review R2, I have review R3. For review R1, I have vector V1. For review R2, I have vector V2. For review R3, I have vector V3. Yes. What does it mean? Distance between V1, V2. Distance between V1, V2 is less than distance between V1, V3. Remember that inversion of sign. Just see here you are greater than, here you have less than. You have inversion of sign. You can see the inversion of remember inversion of sign here. If they are more similar, they are very close. They are very closer. In nutshell, if 2 reviews R1 and R2, I can say like this. Let me say let me say like this, if two reviews R1, comma R2 are more similar, then V1 and V2 must be closed. V1 and V2 must be closed, isn't it? Must be closed. That's what it means geometrically. Geometrically, let's look at, let's assume, otherwise let me assume like this. Let's assume I have 3 reviews here. Let me say this is V2, let me say this is V1, this is review 1. For each review I have a vector. Let me say this is V3. What does it mean? This V1 is, it is corresponding to review 1. This V2 is a vector corresponding to review 2. This V3 is a vector corresponding to review 3, isn't it? If you see the geometrical distance between V1 and V2 is less than geometrical distance between V1 and V3. Now, what I want is, since from English similarity, I can say English similarity, let me write like this, English similarity V1 between V1 comma V2 is greater than English similarity between V1 comma V3, isn't it? What is the distance between V1 and V2? I can say length. I can say length of V1 minus V2 is less than length of V1 minus V3, isn't it? This length is bigger one. V1, V3 is bigger and V1, V2 is smaller, isn't it? Which means similar points are closer. I can say similar points are closer, isn't it? That's what it says. Similar points are closer. Similar points must be closer. Even if you go back and refer our this diagram, just see this one. What it says, all of your positive reviews are close to each other, isn't it? That's what we discussed. All positive reviews, all my positive reviews. These are positive reviews. These are positive reviews. These are negative reviews. Similar points are closer. Negative reviews, isn't it? I can say all of your positive reviews are close together and all of your negative reviews are close together, isn't it? If it is the case, if all your positive points are grouped like this, if your all positive points are grouped like this and all your negative points are grouped like this, but your negative points are grouped but they are farther away from positive points, these negative points are farther away from positive points, then it is much more easier for us to find the separating plane, isn't it? Means first what am I saying? First you have to convert text, you have to convert your text into d-dimensional vector, isn't it? D-dimensional vector, isn't it? Text must be converted into d-dimensional vector. Find that similar text must be closer geometrically. Find this one. How will you find? Find this one such that similar text must be similar text. Similar text must be closer geometrically. Similar text must be closed geometrically. This is very, very important. It means similar text must be closed geometrically. We know what is geometrical close means. It means computing the geometrical distance. We will use this to explore multiple techniques. This concept, we will use this concept to understand the multiple techniques. Like in next lecture, I will start discussing these techniques like bag of words, TF, IDF, yes, word to vec, and average word to vec, and TF, IDF word to vec. I will make use all these concepts in understanding these techniques. These are strategies. These are strategies to convert text into d-dimensional vector. All these are very, very efficient techniques. These are very useful in understanding this sentiment analysis, in understanding polarity. Time being just to go through this lecture so that in my next class I will start techniques. I will start with bag of words. Thank you very much.